All right, so we're going to write down, is there a link between the amount of cigarette smoking in countries and death rates from coronary heart disease? Um, Below is a computer output from a regression analysis of this relationship for 14 randomly selected countries from around the world, along with a residual plot. The explanatory variable is annual consumption of cigarettes per person, and the response variable is annual death rates from coronary heart disease per 100,000 people. So for number one, it's asking us, what is the equation of the least square regression line based on data and define any variables? So this is something you already should know how to do. We're going to get our, first just set up our variables. So we're going to have that y with the hat over it. That hat, remember, means this for predicted value. And then x. Now we just got to find what our slope and our y-intercepts are going to be. So to get the slope and y-intercept, that's something that you just get from your computer output table that we learned about last class period. So our slope is going to be this bottom number right here. And then the number on top of that, 65.44, that's going to be your y-intercept. And then this is going to be your slope. So that's where you get those two different numbers from. A way you can think about that is a constant. The y-intercept is a constant, so the number across from constant is going to be your y-intercept, and then the other number beneath it is going to be the slope. So you just write out our equation just like I did right here, and then it asks us to define the variables. So the explanatory variable, or x variable, is the annual cigarette consumption rate on average per person. So how many cigarettes are going to, the average person, if you average everybody together, even the people that don't smoke and the people that smoke a lot, on average, how many cigarettes they smoke per year. And then that's going to have an effect on the predicted death rate. So that's what our prediction variable, our y variable, is going to be. Now going on to 2, it says interpret the slope of the regression line. So remember, anytime we're interpreting the slope, we think about it. What happens every time we increase x by 1, our y variable is going to increase by the amount of our slope. So in context with this problem, for every increase of 1 cigarette consumption per person on average, would you expect the death rate from CHD to go up by the amount of our slope, which is 0.02268. So that's how we interpret the slope of the regression line. Skip number 3, go on to number 4. It's asking us to check the different conditions. So the first thing we want to check is linear. So you can look at the scatter plot if you had a scatter plot, and if it looks like it's roughly linear, then that condition would check. You can also look at the residual plot, which is what we're going to do right now because they didn't give us a scatter plot. So remember, for a residual plot, if the points are randomly scattered, that means the linear model is a good fit. If the lines formed any type of pattern, like a curve, then a linear model would not be a good fit. If we look at this residual plot right here, we can see that they're pretty randomly scattered, so we can determine that it is it is a linear regression. Then independent, we can assume that their countries were selected independently, meaning one selection didn't have an effect on the other. Normal, we're not given any graphs of the residuals. So if we had a graph of the residuals like a histogram or dot plot, then we could check. But if we're not, we're just going to assume that it is. The equal standard deviation. So the way that basically means is if we look at our residual plot, do our points look like they're pretty evenly spaced out throughout, going from left to right? So you can see as we're going from left to right, there's kind of a good mix between ones that are high and low, and if they're far away, or if they're close to that residual of 0. So it's a pretty equal representation. It's kind of randomly selected there. So we are going to assume that one is as well. And then the last one is random selection. All the countries were selected at random. So I know these are a lot of conditions, but really you just want to memorize them and then just essentially just put those check marks, because like I said, most of the time they're just going to want you to know that what all those conditions are. You just write a really brief explanation like I did for these, and that'll be fine. All right, so now going on to part 5 is asking us to construct a 90% confidence interval for the slope of the regression line. So this is basically the slope that is given to us in our regression output table right here. Okay, that's just from one sample, so that's not from the population. So if we construct a confidence interval, that's going to give us a better idea of where the true slope of this regression line would be for the population. So the way we construct that, we take our sample slope and we put that as our first number. That's like our point estimate. So the slope that's given to you in the regression output table, that's what you put there. And then for your 90% confidence interval, next thing we got to do is we got to do our critical t-score. So for your critical t-score, same thing that we did for all of our other confidence intervals. Since we have 90 in the middle, that means that we're going to have 5% left over in the tail. So you're going to do inverse t and put down 0.05 for the area. And then your degrees of freedom are going to be sample size minus 1. And I believe we had a sample size of 14. Yeah, 14. So then you put 12, because it's sample size minus 2 for these regression, which again is different from proportion and mean confidence intervals. So make sure you remember that slightly different rule. When you plug that into your calculator, it comes out to 1.782. And then we multiply it by our standard deviation. Now, this is the nice thing about these regression problems, is that it gives you the standard deviation or standard error, just another word for standard deviation, in the problem. So this is where we're going to find it. So we go back to our computer output table, and standard, this SE coefficient, that's going to be our standard error. We want the one that corresponds to the slope, which is right next to it, which is the 0.01926. So that's going to be where you get your standard error from for the slope. So it's going to be directly to the right of your slope value. And just, again, read that column, standard error, and it's going to help you know where that is. So then you just plug that in right here. Because remember, when we did mean and proportion, we had to do that whole calculation, but that's given to us already. So it actually makes the calculation part a lot easier. So we multiply that standard error times the critical t-score together, and that gives us our margin of error. And we add or subtract that to get our confidence interval. So we can see our confidence interval goes from a slope of negative 0.01162 to positive 0.05698. And then we just interpret that. So we say we are 90% confident that the interval from negative 0.0116 to 0.0570, and I just rounded it from my interpretation. You could have included the non-rounded version from your answer as well. It's not going to make a big difference. Captures the actual slope of the population regression line relating annual deaths from CHD per 1,000 people to annual cigarette consumption. So essentially what you're going to do for your interpretation, you're just going to say the interval, you insert your interval, it captures the actual slope of the regression line, and you want to use that context, so you'd say the regression line between your x variable and your y variable, to make sure we have that contextual part to it. Then going on number 6, it said if we were to perform a hypothesis test where our slope equals 0 and slope does not equal 0, and these big symbol B's right here, these uppercase B's with a little kind of tail on it, that just means the regression slope for the population, so the actual regression slope. At the 10% or 0.1 significance level, what would you conclude? So you're asking us the 0.1 significance level because our confidence interval is 90%. So 90% confidence interval goes to a 0.1 significance level. So if we look at our confidence interval, 0 is included in our confidence interval. So that means that we don't have statistically significant evidence to reject the null hypothesis because the null hypothesis value is included in our confidence interval, that null hypothesis value of 0, so we don't have any, we don't really have any evidence to say that zeros could possibly be outside that interval. So our interpretation, we would conclude that since the actual slope from the regression is 0, or since 0 is included in our confidence interval, we do not have evidence to reject the null hypothesis. We do not have statistically significant evidence to say that cigarette consumption rate affects the death rate by CHD. So that first sentence, stating whether you're rejecting or failing to reject the null hypothesis, and then the bottom one is you have that interpretation sentence. So that's how you go through these problems. I know they're kind of long, but this next problem that I give to you is kind of broken down into different parts as well.